Hello. Hi, everyone. This is Pooja Ranjan. I work in the software cloud providing industry in the San Francisco Bay Area. I have been working here for over a decade, and I'm very excited to be here at the Conference 42 DevOps of 2026. What a great way to start the year. Without further ado, let's get started. I'll talk a little bit about myself and then a little bit about the topic I'm trying to cover, something that's very fundamental for DevOps. And yeah, you can reach out to me and connect with me for questions. So let me share my screen and we will get started. Okay. Yeah, a little bit more about me on the first slide. As I've mentioned, I am focusing on delivering enterprise scale level SaaS software services. I have worked across different companies that provide different kinds of microservices, mostly in the B2B format. My customers have largely been other businesses, educational institutions, organizations, and yeah, other B2B businesses. So coming to why am I choosing to talk about what I'm talking about today is because of the impact that it has on software as an industry. So all of us have definitely heard about like SaaS, software as a service model, which is a cloud model where any software that a provider builds is built, licensed, delivered, and managed by the provider or the owner of the software. And it's delivered over the internet. It allows the end user to access applications via a web browser, or they can have a subscription that they can use and then install or use that software locally. What are the benefits of using the software as a service model? Obviously, it helps you with costs. So, smaller vendors, businesses do not need to worry about building, maintaining, shipping their own software. Smaller businesses who are trying to sell smaller items or who are trying to run some sort of analysis or data sciencey algorithms, they do not need to worry about building their own infrastructure, maintaining that infrastructure from scratch, worrying about security, reliability, all of that. How do we how do we provide this all of these things to an end user? And then how do we continuously keep providing it? And then how do we maintain all regulations and standards that are imposed by different organizations in different companies and different countries? So that's the summary of what we're going to do, what we're going to talk about here. So, why is this topic important? Question number one. It's very important because SaaS is a market hogger, a market grabber in terms of revenue. All software services applications, if you look at the numbers that the companies in the Silicon Valley generate, the number is upwards of 350 billion US dollars in annual revenue. And this delivery comes at the cost of promising like availability, service availability. So when we're talking about a small vendor who wants to, for example, host a small handicraft website on an already existing platform, they are agreeing to use that platform as a service. And then the vendor will have a contract for them. Okay, we will keep your service up and running for 99.9% of the time, and this is the amount that you will owe us for your usage. Something like that, a rental contract. And also, now this is the amount of time we're saving through automation. I'm going to come to this a little later. Before that, let's come to why is this why is compliance and delivery, all of these important when you are a cloud vendor? Working on the cloud provider side, something that you will deeply notice is that just like every other software delivery model, software as a service also follows like different stages of software delivery. So if you are delivering SaaS for any provider or vendor, what you will see is that you have to follow your SDLC steps, the software development lifecycle steps. One of which could be your feature planning. It could be followed by architectural design. And then we do talk about development, we talk about automated testing, we talk about deployment, and then we talk about monitoring and improving how the service works. So here is where I would like to get into a little bit of depth. So as software in different stages of software delivery, right? There are different categories of things that are important. And there are different stakeholders to every specific category that we're talking about. For example, when we talk about the first stage, when you're trying to gather requirements, like what is a good requirement for a cloud vendor to deliver? It's usually gathered by a team of product managers who have the nerve and the pulse for what the market actually wants, what the customer actually wants. And and a customer can either approach them directly, or and in the current times, there's so much AI tooling embedded into our systems to determine what's the what next feature that the customer wants, so we can stay ahead of the curve. Data scientists nowadays, they use sophisticated tools like large language data models to determine interesting patterns from structured and unstructured data to predict the list of soon to be most desirable software features. And this can be in any industry: finance, healthcare, commerce, journalism, content creation, engineering, aviation, planning or travel, all these things. So, based on the data that's collected in these stages, either through automation or through like direct customer interaction, a project plan is put together. So we try to understand the requirements that we're trying to build, what's the target audience that we're building for, what's the projected adoption rate that we think it will be, and how will that be accepted in the industry, and how will we gather feedback basically. So compliance, now about this rough stage, if we want to talk about how are we making sure that compliance isn't fades. So compliance at this stage usually is a bunch of legalities. So there are contracts that are signed between customers and clients. There are some non-disclosure agreements, maybe. It's more to do with the legal side of things. But these contracts usually enforce the SLA that people are looking for. An SLA is nothing but a service level agreement. It's regarding the availability and scaling requirements of a feature or service. For example, a simple contract in a clause could be like, hey, I will host my website on your platform if you guarantee me 99.99% availability. So, what is 99.99% availability? It's the difference between, I would say, having a service up and running, like your website up and running, for less than maybe 4 hours annually. So, there could be some downtime that could be due to outages that the vendor could have, migrations, or just internet blips, or any other performance related bottleneck. But in a 99.95% agreement, what we would say is that, hey, we want the service to be up and running for less than, or always, apart from like under less than 4 hours per year. But if you up this service level contract and say, okay, now we're going to talk about 99.99% availability, what you're saying is that we want the service to be up and running for less than maybe 50 minutes in a year. So that's a lot of difference. Although the number looks uh, like pretty similar, the difference is too much, because for us to promise, and that's why the most stable cloud providers are able to provide more stable numbers. So this kind of compliance and delivery standards that have to be maintained, these level contracts are signed when we are doing like feature planning. In step one, we are talking about, hey, can we keep the feature up and running for so long? And if there's a deviation, then there are like various clauses in the contract to make up for the monetary losses. Coming to the next stage, software architects, and now we're talking about architectural design and review. So now we have listed it out. We know what we're trying to build. We have an agreement with the customer on what to build. We have used certain AI and compliance strategies to ensure that everything is secured. Now talking about what are we going to do when there are software architects, when we're talking about designing the actual feature that we're going to deliver to a customer. So software architects and senior software engineers work to design components of the feature or service. There are multiple meetings and sync ups to determine how are we going to do something like this. You can say that there are unified modeling language diagrams and tools, chatbots that you could use to actually draw these diagrams. What you're trying to see is that, hey, are we being able to draw a good behavioral diagram, the sequence of how data is going to flow between the different modules of your classes, how will Indian object-oriented system, and or what kind of code design patterns are you going to use, be it the builder pattern or the singleton pattern, abstract pattern. There are a lot of tools that could be used to automate the entire process. That could be Argo, it could be Visio, it could be Autodesk, and anything. And compliance again at this stage would be ensuring that everything that we're using here is either open source or any third-party software that you're using here. It's either open source, which is basically crowdsourced software for public consumption, or has gone through proper license purchase procedures. Compliance also involves like doing a full security posture review of the proposed software. So we could send it to a security design team internally. Most organizations have a full-fledged security team that would do a full-fledged analysis of whatever service or feature that you're trying to ship, and they will tell you why should you do or should you not do what you're doing to make sure that we're not exposing the service or any of these hosting requirements to any sort of vulnerabilities. There could be denial of service, there could be cross-site scripting. We do not want any of this to happen, and that's why full review is conducted. If any leaks are found, then the design goes back to the architecture board, and then all these features are reviewed again and ensure that we are complying with all the security postures within the provider's organization to ensure that we're not delivering anything that is vulnerable to security attacks. So stage 3 here is largely where you're actually trying to build it. That this is when the engineers become a lot more involved. So we're talking about software development time. These will be people who will come in, build their specific tool. They will use programming languages, Java, Python, C++, any version control system, maybe Git, Perforce. Yeah, here a list of some tools that are usually used in this process can be seen here. So you're going to use, so SaaS delivery systems heavily rely on application programming interfaces like APIs to enforce the right boundaries of abstraction between a user and a service interaction. And companies invest heavily in building and automating APIs. So that's one thing. And API specification generation is also a specific tool set that most companies have internally. They have their own internal versions of it. So when we are trying to develop the feature that a customer was asking us or something that was driven by the market, how do you ensure that you are compliant to industry standards, country level standards? How do you ensure that everything is compliant so that we can uphold the quality level? It's usually largely depends on, in the development stage, it largely depends on using very good coding practices. So proper data abstraction, automated generation of maybe unit tests, and validating a smallest functional component in code, like writing tests to validate every small component, every feature set, every code path in the flow is important. And reiterating to ensure that the design document is agreed upon. So if you're making a change, if it feels technically infeasible or feels like it's exposing a vulnerability, it can go back to the architects or the security organization for a re-review. And then the design document is revised, and then we can go ahead and make the new changes that a developer is proposing. Then there are code. So CI/CD this is exactly where CI/CD actually starts. CI/CD actually means continuous integration and continuous delivery ecosystem. Here is when, so once a developer is ready with this new feature, or while he's working on this new feature, he can continuously keep pushing his code into the company's remote repositories. And from there, we can request for code reviews. Code reviews are done to maintain the standards of compliance. So if coding is introducing something that might cause a data leak or a security leak, then in the current times, there are a lot of AI code chat review bots that would prompt and that would fix it, that would prompt you the changes, that would make suggestions, and sometimes even suggest small random fixes in your code. And then it also goes through another round of, and then there are like linter tools. Yeah, there are linter tools that bots look at. It's like a bot that cleans up the code, cleans up code like spaces instead of tabs, checks for code vulnerabilities like outdated package versions that could become security threats. So there are a lot of scanner tools that run inside the system to make sure that we don't push either a vulnerable version or any package dependency that could cause a security breach. Peer engineers are also heavily involved in this process. They hold a code review quality power. Pull requests are approved after thoroughly reviewing them, and then merged into the main master repository after all these checks are complete. So stage 4 is where compliance. So going back to this diagram, these steps. So now what we're saying is that we are building our code. We are making sure that we have gathered our requirements from product teams. We have had several design meeting rounds. We've done all of that. We are now into development. We are almost code complete. Our product is almost ready to go out. But that is when we start looking at another very critical phase in this process, which is called the quality deliverable. So, how do we automate and test everything that we are building? We need to write comprehensive test suites to validate functionality, performance, compliance requirements, and so. So, in this stage, what we are doing is that we are shifting our focus on quality. What we're saying is that now we are going to conduct like very rigorous tests, functional tests, integration tests, regression tests, and security tests. We're going to write test code using JUnit, Mocha, JMeter, a lot of these tools out there. Some of these auto generate some amount of code. And then we're going to run these tests on the new code that we've written. And we're also going to run it on the code that was existing to make sure that we haven't introduced a new bug in this process of building. There are different code coverage tools like Clover. What they ensure is that we are at least maintaining code coverage in terms of testing. The lines of code that we've written, at least 95% or above code is it's the standard industry practice that we do. We want test coverage that goes across like always above 95%. So we know that the code that we're shipping out is less buggy. So I would like to actually, yeah, let's talk about this a little more. To understand software testing, I would say there are two broad categories. So we want to ensure that because these are paid customers that we are shipping to as a vendor, you want to ensure that code that you've written is very thoroughly written and tested. There are two categories here broadly: black box testing and white box testing, what you could say. Black box is where the component that is being built, whatever feature or service that you're building, is treated as just as a functional unit. So without worrying about any internal implementation, your test cases are purely designed based on the product documentation that you have, like the end-to-end user functionality that the service is supposed to provide. And then you do some stress tests to ensure that there are no outliers. So several organizations, cloud providers these days, use orchestration services like Kubernetes to containerize and parallelize the running of functional tests and to continuously keep running it in their production environments back to back all the time. And no button click is required. It's totally touchless. And you can use like a cron job sequence, program something like a cron job sequence into your systems to make sure that tests run against your production environments every few minutes. That's what black box testing does. And then when we talk about white box testing here, we're also, yeah, so these are all the testing dependency checks, static analysis that we do. If we talk about white box testing now, so white box testing is more evolved test plan and focuses on code workflows. And it makes sure that you catch issues like an infinite loop, null pointer exception, and you prevent the wastage of processing time. Sustainability is a big deal. So we'll talk about that a little later. But we want to write code that is optimized and that has the minimal amount of execution time so for the user can have a faster processing time and faster reaction time, and that'll mean that we are providing you with a good user experience, and we're also optimizing the usage of the underlying hardware that we are hosting the service on. So talking about certain standards that now when we talk about compliance and when it comes to so in US most of the times there are a bunch of we spoke about a few data governance standards, but there are two specific standards that I would like to call out. One is the SOX compliance standard. It's like a federal regulatory standard that all SaaS provider companies, all cloud provider companies have to stick to. And this act enforces that robust testing of software components with clear defined end results and goals have to be documented in your system, and they have to be available if and when an audit happens. So every ticket, every feature that you're building should have a well-defined acceptance criteria on when is this product or the service declared or acceptably complete for the end user. That criteria has to be defined, and then you have to explain how do you meet that. And then and you have to document, you can document them in any form. You can have any internal tool for documentation, or you could use standard tools like Jira, where they come in with these specific fields and you can document those answers there. And these results have to be available all the time for audits if needed. There's another compliance standard that's really important, especially for companies that provide any sort of federal services. So the United States, a lot of cloud providing companies or database companies or third party companies provide services to the federal government. And of course, data there is highly secure and has to jump through a lot more security loopholes for anybody to even get access to deploy or maintain a service for these customers. But the one standard that they specifically ask for is a VPAT compliance, which is called a voluntary product accessibility template compliance. What happens, the requirement of this template is that they want us to keep any service or any offering inclusive to people who have any visual or audio deficiencies. So you are supposed to conduct a thorough test of your software system, and you could use tools like the screen reader, and then you are supposed to document all your results into an accessibility conforming report and generate like screenshots of all your service endpoints that are accessible to a customer, show how, and this applies to the UI bits of it, so not the API interactions, but the UI part of whatever you are delivering to a customer. All those things have to be accessible. So these standards have to be met, and that's why there are different tools that companies use to make sure that these standards are met. And again, these can be audited at any point of time, and you will have to be ready with reports. And these compliance certifications are regenerated every year. So the evaluation could happen at random time, but they definitely happen year after year. So yeah, we spoke about service reliability a little bit at the beginning. What's the difference between 99.99 versus 99.95? Why are we trying to automate all these workflows here? So just to wrap up that last stage, and then I want to tie this back into this stage. So now that you've built and shipped your service, you're ready to ship it out. You are gonna go and do some CI/CD kind of deployment where you use a deployment tool, GitLab, Bamboo. You build it. You use Python or Bash scripts to provide assert logic, confirm that all automated tests have passed. You're now pushing it using you might want to do some load test using Locust or JMeter, and then so that you can spawn like millions of process threads or user threads per second and mimic like how would a real end user perform in these situations. Once you have, and this is essential for us to confirm that our SLA that we have promising the customer will actually be available. So compliance standards not only apply to successful availability, but also to the latency of server requests. So every request response that is expected to succeed within 500 milliseconds. So if you're saying that 70% of calls, an average 70% of the API calls or UI call made by a customer, or request made by a customer, should take under 500 milliseconds. And after all these rigorous tests, we are now deploying our software. Once it passes these tests, we're now deploying it to every customer region or like a geographical region where our data centers and warehouses are located. The final stage where we have now deployed our service and we are getting customer feedback, we're trying to improve. Again, at any point, the SDLC lifecycle goes back to stage one to stage here. Yeah. So once we have tested, production monitoring is happening now. At any point, it can go back to in the loop for the stages 1, 2, 3, 4, 5 again. So we continuously keep improving and optimizing our service while maintaining our service like productionally operational to keep it productionally operational. Usage data and metrics are the most important thing. So tracking it is possible by using tools like Grafana. You can save your data for data warehouses, and then you can mine it for interesting usage patterns. There are tools like Weka that will help you pre-process this data and then feed it to data models and then find interesting correlations. There are several services out there in the market that help you run these kind of analysis. Compliance at this stage is largely like data handling governance, every possible access control, isolation between customer and data, and between customer data as it's implemented, logging tools are audited for privacy, software upgrades, dependent packages, version upgrades are constantly deployed to ensure latest and best security posture. Horizontal scaling is possible sometimes because you want to add more configurations or add more servers to the fleet to deal with the growing requests of servers. And then vertical scaling is possible sometimes you just add more memory and more processing to an existing server. So this all the scaling of this is dependent on the predicted load. We get this load information from all the AI tools that we run. Tools like Jira, SD, they help us like set up alarms. So if something goes wrong, if there's less disk space left on the server, for example, it can alarm us and tell us like, hey, you just have 30% memory available on this one. So data governance. So once we deal with all these challenges, or we continuously keep dealing with all these challenges in production monitoring, why do we deal with all of these? Now, the point of managing all these automations and trustworthy delivery is for these three strong reasons. One is trustworthy delivery. So we want to be sure that we are compliant in every way so that a customer can place their full trust in us and we could be one of the strong players in the market. The second is to save engineer time because production and maintenance is an ongoing effort. It's constant, it never ends. It never ever ends. And in a cloud providing company, like engineers spend over 30% of the time just maintaining software. And then there are full DevOps teams deployed for this. So we want to save the time, but we want to keep it very streamlined, and we want to keep automating everything that can be automated. So the time that it takes for us to build something and to ship something is very minimal and very optimal. And of course, for scalability in the future. So given that every cloud providing company is actually just growing and growing, and there are several different data centers that we are expanding to globally, you want to minimize the amount of time it takes for you to build in one region and then ship and deploy to every other region in the world. Yeah, that's the summary of how things work in a cloud provider setup for a SaaS company. The key takeaways usually are that, yeah, you start working on these compliance requirements as early as possible, integrate it into every step of your journey as you are going through development and shipping. You put it under monitor, you have quantifiable metrics that you measure at every point of time. You instrument your code, you surface out all these metrics that you need to keep your service, to measure the quality of your service. You automate as much as you can, free up more engineer time, and have a more streamlined way of deploying things. And that automatically brings us to the fourth point, which is sustainability. So the less time you spend, the more optimized your hardware and your software is, the smaller your carbon footprint will be, and you will continue shipping things to your customers on time and the most efficient manner. Yep, that's pretty much it for me, folks. Thank you for your time. Thank you, DevOps, for letting me present. Talk to you all in another conference. Thank you.